So now we'll get into the main topic for today is the IHE PCD. It's the main part of IHE PCD is interoperability. Now we're going to be talking about communicating between different systems and different devices. AMI defines it, and IEEE defines it as well. AMI gets specific, saying medical devices and clinical systems to communicate to safely fulfill an intended purpose. It's sponsored by American College of Clinical Engineering, HEMS, and of course AMI. It's built upon IEEE and HL7 standards, and this is an open source protocol, so different vendors could work on it. The medical equipment management, as Ted mentioned, this is the core piece here. This is where we actually get to leverage that IT information to benefit clinical engineering directly, whether we're assisting with workflows or quality. Things we'd be getting would be unique device locations, battery management, RTLS, and even configuration data. So as we get these alerts from the system, we could do two things. We could create a work order, and then we could send out an alert to the user. Some of the benefits of having the alert management, of course, is reduced downtime, having a proactive as opposed to a reactive work method. If something's drifting out of range or a battery is getting low or a temperature, we'll create a work order automatically based on the signal coming out from the device itself. And then you could leverage the utilization service as well too to help you find devices that aren't being used. I should mention all these signals are coming from the devices themselves, and then the manufacturers determine what signals are coming from their devices. EQ2 is one of the only CMMS providers that had proven IHE PCD connectivity at the Connectathon, HEMS, and AMI. You can see some of the providers below that we've interfaced with. And in the lower left, we have two companies highlighted, Capsule Tech, which is a middleware provider, and then Guard RFID for location services. Many of you are familiar with HEMS and AMI. The Connectathon is kind of unique to IHE. It's a 5-day event where we have education services, networking, more or less you're discussing between the different customers to, what type of observations do you want to see from devices, and then of course testing to verify everything works as designed. There's 5 key profiles in IHE PCD. When this domain for CMMS would be your alert configuration management. That's most of your alarm data. Your device enterprise communication, which is trending, and these devices are going to the EMR. The infusion pump event communication, it's kind of split between nursing and biomed. So things like infusion complete, errand line could notify a nurse, while things with having trouble with the battery or some other kind of failure with the device would go to the CMMS. The bottom 2 protocols are both in the MEM world, the MEM LNS, which is the location services, and then the MEM DMC, which is medical equipment management, device to management communication. And these are where all the observations, the different statuses and triggers that are going out to open work orders. And EQ2 developed this protocol. So everything with MEM-DMC is referred to as an observation. So all these status or configuration changes are called observations. And these could be anything from metered PMs to knowing when a device is turned on, or even if a network configuration is about to change. As we mentioned, Capsule Tech on the Connectathon slide, this is how those signals are known. Everything's connected on your network. All your medical devices, naturally your CMMS is on the network. So your middleware is looking at all this network communication, filtering the data, determining what is an observation, and then it transforms that data so that it goes to the correct information system, such as alarm management for nursing or going to an EMR. And then, of course, anything asset management, which is where HEMS or your compliant CMS will work. Some of these observations, as Ted mentioned, were things such as battery operation, self-test status, so whether a self-test passes or fails, battery status levels, or actually the percent complete charge. And then actually if something's switching between battery and main and then back to battery, it could be a potential battery failure. That could also be one of the signals to trigger an observation and open up a work order. Acquiring network information is one of the key things as well, and then it could populate your network fields in your CMMS. So if a board were replaced and the vendor changed a NIC card inside the ultrasound machine, naturally there'd be a new MAC address that would be interpreted and put into your CMMS. Getting utilization information about the device. You know when the meter PMs are created, so if something has to be done at 500 hours or 1,000 hours, it would raise the signal and then trigger the event to create that metered PM. And it could help you a bit with equipment replacement planning because you know exactly how many hours a device was used. And then getting status. Status information is useful as you're trying to locate pieces of equipment for PM or for nursing. They say they can't find another device. Plus, you know when things are on or off or if they're in use. And you can interpret some of these utilization patterns as well as you're trying to plan your day to do your preventive maintenance. If you're planning on doing intensive care, you would see every bed is occupied. You would know you need to work in a different area. Likewise, if something's being used heavily between 7 and 1 p.m., you could schedule your maintenance after the peak zone. And then, of course, the integration with RTLS, getting the information, knowing where your devices are, would update the location in your CMMS as well. And if a device were outside of the networked area or wired area, it would at least let you know the last place it was seen in the hospital. So our application is a combination of having the floor plans. So you would need your floor plans put into the system. The purple dots are pieces of equipment. In the upper left is where you're filtering between your different buildings and floors. And number one lets you get into additional filtering. And then as you select the device highlighted in yellow, it'll give you your device information. So a close-up, if we look at the building and the floor, we could choose which building or which floor we want to work on or investigate for assets. We could then filter by devices that are due for PM, something that's overdue for PM, something that's affected by a recall and alert, or it's something that's an alarm state. The in-use checkbox actually causes those dots to toggle on and off, so you can see which devices are in use. If we select a device, the color turns yellow, so you see your selected device, which room we're in, and then that retrieves the information for the asset's attributes, control number, serial number, et cetera, including pictures if you have pictures in your CMMS. So that's the overview of the IHE PCD interface. It's usually profiled when Amy runs usually have a showcase on the field in the exhibit hall because it requires vendors that have the medical equipment, the software, and middleware. So some of the benefits are reduced downtime because you're doing proactive maintenance, increased response time because the machines themselves could request service. So you may have a balloon pump or a defibrillator that's charging, a battery failure is detected, the machine raises a flag, creates the work order, all independent of having a user finding a problem. Utilization-based PMs are generated automatically. You get better device utilization because you can see which devices are really used. Especially with equipment planning, you might have something that's there several years and looking at the hours and may only have 100 hours. And then, of course, better PM management because it helps you schedule your workload more appropriately.